I don't feel that great, so I'm going to have you guys basically be up on the board all day today. I know. It's great. It's a good trade-off. Uh, 23. Okay, Stephen, here's what I was hoping we could do to start with. On that first question, we're just going to draw a line between the 2 points. So it's called a secant line. I know a couple of you had that question at the end of the last packet. Whoa, what happened there? All right, let's take the palm and start that one over. And we'll cheat. Instead of drawing, oh, that's actually pretty good. I was going to say, I have a near impossible time trying to draw straight lines up there. Are there any spots on that function between the 2 points that mimic the same slope as that line? Do you kind of understand what I'm trying to ask? Yeah. So, we've got a curved function. Are there any places on that curved function that have the exact same slope as what you just drew? Well, the red line you just drew, yes. I would say probably roughly right. Oh, I can't. Oh. I would say roughly a little bit past the top of that hump. Yeah, just a little bit past, because that would have. Somebody else know what I'm trying to explain? I don't know how else to say it differently, even though what you're doing is so. Yeah, parallel to that. So here, even better. Let me duplicate your line. And if I take that same line and I put it right about there, I would say that spot on the graph has about the same slope. Okay, you agree with that one? Yeah. Is there any other spots on that graph between the 2 points that have that same slope? Here, I'll duplicate it again. We'll get creative. Now you can just drag it. Perfect. I was going to say right about down there somewhere, right before the hump. Okay, excellent. So this is kind of what we're discussing today. It's called the mean value theorem. And it's the fact that there's going to be some locations between the 2 points that will have the same slope that you just drew. So this is going to be called the average slope, the secant line. This is the instantaneous slope. So the mean value theorem is that if you have a continuous and differentiable function, so like just a normal curve, you're guaranteed that the instantaneous slope would be the exact same as the average slope between the 2 endpoints, at least one place. So that's the mean value theorem. Right now, it probably seems pretty useless, pointless to you. That's okay. It'll have uses. Okay, now, these pictures here are supposed to lead us to the fact that I just told us. 27. Right here. Can you draw the secant line between the 2 points on the next one? Yeah. Okay. Is there any spots on that graph where the instantaneous slope would be parallel or match it? It would have to be between the 2 points you just drew, though. I would agree. I kind of already gave away the answer when I said it. When I said continuous and differentiable. Do you remember what? It's been a little while since we used those. Do you remember what differentiable means?
You always take the derivative of it.
Yeah. Is there any spots on that one that you can't find the slope?
Right here.
Correct. So that particular graph is not differentiable between the two endpoints. So that's why we're not guaranteed a spot. Perfect. I know these aren't super difficult today, but everybody seems to get stage fright going to the front of the room though. It's just kind of a given. 28. Oh, really? Didn't we just have 27? So this spot right here is not the endpoint. These are the two endpoints. Yeah. Okay, is there any locations between those 2 points that has the same slope? I would say probably right there. To me, this looks like a slope of 0, so like flat. So the top of a curve generally is always going to have that spot right there. Yeah, right. I know it's tough to draw it. That's perfect. Now, this one's obviously not continuous and differentiable in the middle. But we still have a spot where the instantaneous slope matched the secant, or the average slope. So the mean value theorem doesn't say that it's impossible to have matching slopes. The mean value theorem is just saying that if it's continuous and differentiable, we're guaranteed at least one spot. So like this first graph that we drew, it's continuous and differentiable, we're guaranteed one spot where they're the same. Should we do the fourth one? Do we need to draw that? I feel like you guys are smart enough to get that point down. Okay? Oh, my bad. I forgot. There's 2 theorems, even though the second one's useless. Okay, so here is the official drawing of the mean value theorem, and here is the formula. Where's the highlighter? Highlighter. This essentially is what you're going to see, and it'll be written in the questions most of the time. So you're not going to have to memorize this. But this is the formula for mean value theorem. Now, we get somebody who doesn't have to come up to the board, but I'm hoping can help explain. 6. Oh, Lord. Have you had your headphones in the whole time? Guaranteed, because I literally just said you probably don't even need to come up to the board for this one.
Okay,
But now that you're up there, might as well stay now that you're there, yeah. Okay. Now, there's nothing for you to write down. But we'll just have you stand in the front. And, do you remember what f prime of c, what does that stand for? Okay, so the instantaneous slope. And c represents a random place between a and b. Whenever we have c, that's what it's for. Okay, what does this say? Yeah, I mean, I should have phrased that differently. What does it stand for? Yeah. Okay, so in calc terms, average slope. So this is basically saying the instantaneous slope is going to be equal to the average slope. Our goal sometimes will be to find this c value. Other times you'll just be asked if they're guaranteed to be one. There's going to be different kind of questions given, but this is the mean value theorem in a formula. It is traditionally written in the problems. Are you still listening to music? Okay. You're the reason you're going to get phones banned in school. There's nothing more to do. Yep. You guys are your own worst enemies. If somebody tells you you don't have to do something, 2/3 of you guys went on your phones immediately. What are you going to do when nobody tells you can't go on your phone? Especially when you're paying like $60,000 a year to go to school and you spend half of the time on the phone in school. Like, it's kind of wasting your money. Oy. $20. Is that anybody? Oh, Jesse. Probably don't need to come up for this one either. There's nothing to write. How should I phrase this? We had one example like this already. What looks special about this one, or looks different, kind of, than the other ones? It says in it, I don't know if you can read it from where you're at. Okay, perfect. That's all I was looking for. So Rolle's theorem is a very specialized subset of mean value theorem, which says that the two endpoints have to be level or equal, or a slope of 0. To this day, I still don't know why this is a separate theorem. So to me, mean value theorem just says the two endpoints can be whatever. The two endpoints could still be level on mean value theorem, but Rolle's theorem is only this one situation, this one case. And so it's a separate theorem. I still don't really know why. Yeah, or whatever. I mean, I'm not the one making up the rules. So this is going to be called Rolle's theorem. The only difference is the endpoints have to be the same. Okay, now we actually have an activity. You guys look super, super unhappy to be in here today. It can't be because of packets alone. It's a mentally it's a Monday, okay. Was there an AP test on Friday as well? You had 3 AP tests on Friday? Yeah, physics and calc almost always line up together, and it just always happens. We don't ever plan it. But multiple years, we've always had tests on the same days. Oh, it's empty. 36. Come on. 35. I think 35. All right, let's see some fantastic artwork here. Why do you keep saying wait?
Why are the numbers like 0 to like, why is it like?
Oh, they're not even intervals? Correct.
Why do they do that?
To make you angry. Oh yeah, actually that does bother me. It switches from evens to odds midway through. Ooh, that's a big no-no. No, you can't do that.
What?
You can't do that
Why not?
because you don't know those answers.
Oh.
When you're given a table, You don't know any information in between the values. So it does say up top that it's continuous, and I think that's why you connected them. But for all we know, it could like shoot way up or go way down in between those 2 points. Probably doesn't. But whenever you're given a table, that's the only information we know. Okay, nice job. You definitely had the easiest question today. Number 1. Oh, no, he's taking a test. 31. Okay, so it says find the average rate of change from 2 to 9. If you want to use the picture, you can. If you don't, doesn't matter. But we're going from 2 to 9. Oh, you're bringing up the emotional support. Excellent. Good idea. I'm fine with that. The line would be better if we went to the right spots. So you went from 2 to 11 on accident. It's from 2 to 9. I know it's kind of difficult because we can't see the whole page. Okay, how would we find that answer, but we don't have to actually go through the work to do it? Okay, that was a lot of no information being said.
Did you just take these 2 points and then these 2 points and like do 11 minus 4?
Yes. Yeah. Okay, that's the part that I was waiting to hear. So the average rate of change would be 11 minus 4 over 9 minus 2. Okay, nice. $30. Oh, serious? Oh, wow. This one, there's no drawing to do. If you want to sit down, you can. So B says, is G prime of 6 equal to the slope of the secant line that you just drew? Get help? Yeah, you can ask people. Go for it.
Wait, can you say again?
Here, I'll put it on the question. B. Oh, that's right. It's hard to read from there. Is G prime of 6 equal to the slope of the secant line from part A? So you are given information about G. You can poll people if you want to. I think she wants some assistance as if people are willing to offer it too. Am I correct? You guys look like you're trying to discuss. Yeah. Does anybody think they know the answer? Do you want me to call on him?
Yes.
Okay. Sure.
So the question is, this one is this one, right? Correct?
It was between 4 and 9/11.
Are you talking about the one she drew first?
Wait, no, I'm talking about
B?
this question, G prime of 6.
Okay.
So would it be, you use the formula F prime of, well, G prime of the answer, so it would be 6 minus 9 over 12 minus 11. No, 12 minus 11 over 6. 12
So
minus 11
that would find
is 9.
the average slope between 6 and 9.
Oh wait, we'd be using 6 and not 9.
We can't determine it. But
Yeah, G prime 6 has to be determined. Wouldn't the easiest answer just
I don't know. That's what we're trying to
line
answer.
it there? So that would be 302, wouldn't it? You just draw the tangent line. Is it 3/2?
Oh, I'm waiting for more, I'm waiting for you guys to figure something out.
We don't know what the derivative is, we don't have enough,
But
any of
can't
the
you
values
find
around
it
it.
out? You just
Or
do
the
the
function itself.
approximation thing. 13 minus 12 over 7 minus 6.
We can try to estimate the slope, but we don't actually know for sure what the slope is.
Well, then,
That sounds good. Wait, let me do this.
13 minus 12 over 7 minus 6.
is it 3/2?
Oh, I know, that looks like about 3/2, I don't know. I didn't count them. Okay, so if you guys heard that, G prime of 6 stands for the instantaneous slope at 6. This says, is that equal to this slope? Well, we have no idea. So we're not told G prime. We're not told an equation, so there's no way for us to calculate it. We could estimate the slope at 6 by taking points before or after it or whatever, but there's no way for us to actually calculate it. G prime means the instantaneous slope, and we don't know enough information to actually find that out. So we wouldn't know if this is true or not. It might be. We just don't know. That's why your question was definitely so difficult from the start. You were trying to calculate the average, I think, right about at 6. That's what it sounded like to me. Okay, C. Does Rolle's theorem apply on the interval 4 to 9? Number 2. No? 12. Well, that's a big change. 9, 10, 11, 12? Kale? Sure. I think it said 4 to 9, right?
Yeah. 4 here, 9. And is the Rolle's theorem the one that's 0? So then it just wouldn't apply?
Correct. If you didn't want to go by the picture, which you're fine drawing what you did, it has a height of 8 at 4, height of 11 at 9, so they are not level, they're not a slope of 0. If this would have said 4 to 11, wait, I hope that's not the next question. If this would have said 4 to 11, Rolle's theorem would apply. Is that, that's next, I should have known that was the next question. Perfect, though. Okay, are we feeling okay about these 4 now? It does have to be continuous and differentiable for Rolle's as well. This one, that last question in the directions, it said it was.
Oh, okay.
Yeah, otherwise the table we wouldn't know. 32. Excellent. So example 2. Let f be that function. Find the number c that satisfies the conclusion of Rolle's theorem for f on negative 3 to 1. Oh, this is desperate support called in.
Did you find the derivative first?
It's up to you. Do you want me to have you write down the formula to start with? So f prime of c,
I think I remember.
okay? F of b minus f of a.
Oh, that's a D. My bad.
What the heck? I think 2 fingers is like right click or second color. I'm a little confused by your F more than anything.
Oh, my bad.
Is that a B?
Yes, it's a B.
No, the B is legible, the F is not.
Caroline? Okay.
Do you want some assistance?
Yeah.
Okay, so you just found f prime of x. This formula says f prime of c. Thank you. So what is going to be f prime of c?
Whatever this is.
No, well, yes, you just wrote f prime, right?
Yeah.
So the left-hand side of this formula calls for f prime, but it says to use a c instead of an x.
Okay.
So write this same answer you just found. No, leave it. You can leave it, but write it with a c underneath the formula.
Could I just write 2C?
Palm.
Oh.
Equals. Wait, what? No, erase that. Or here, on. Oh, no, erase that. What are we supposed to write on the right-hand side of the equation? I mean, we're kind of running out of space, but what, here, don't be upset.
Oh. That's okay.
Instead, there's nothing wrong with what you wrote, but we just don't have enough space. What should we be putting here?
Oh.
The numbers now. So f of b, which one's b and which one's a?
I'd say -3 is A.
Negative 3 is a, and 1 is b. So f of b is you putting 1 into the equation given. Technically, it doesn't matter, but A is first, B is second. I mean, it's just, the interval is always going to be written as small number, big number. So A, B. Why can't it be 0? Yeah, is that a 2? Plugging 1 in should give you 0.
You plug in,
I'm so confused.
you plug in B minus A into
Oh.
See, I want the old smart board back.
No, he did it wrong.
No, I know he did, but the old smart board was actually just did what it was supposed to do.
9 minus 6 is
So 0,
it's 0.
0,
I thought it was like
minus, okay? So 9 minus 6 minus 3 is also 0. 1 minus negative 3. So nothing you're writing is wrong, but holy man, you got to work on management here. So let's write 2c plus, there you go, equals 0. Thank you.
Thank you. C by itself.
Yep. Perfect. Perfect. Nice. Now, I didn't really say anything about this problem ahead of time. I just kind of wanted to see how well you do on your own. You did great.
Done?
That's all it asked you to find. Okay, one important fact I want to make clear. So You notice how I had him write 2c plus 2. If you write 2x plus 2 on the AP test, they'll mark it wrong. They are very particular and picky about this fact. Because the formula says f prime of c, if you write f prime of x, they mark it wrong because you're like randomly changing the variable on your own. And I know a lot of you just write x out of habit. You want to go by what it says. So I especially want, oh, I suppose you guys don't have it. I was going to say, I wanted you to be able to write this example down. Forgot. That's super annoying, I know.
And the lady in the notes writes X.
Oh, I guarantee I'm probably going to do it on accident sometimes too. But that's a point of emphasis that they made sure to let us know about, that if it says f prime of c, write c. So technically, before you do Rolle's theorem or mean value theorem, you have to check that the conditions are met. And I didn't want to do that quite yet because we're just starting it. So if you check that the conditions are met ahead of time, then yes. Yeah, I know. We're just doing examples to start with here. We're not trying to be official yet. But you're right. Most of the time, it's not going to specify Rolle's theorem or mean value theorem. It'll generally just say or ask. The sports car speedometer, that registered 50 miles an hour. That's very sports car-like. As it passes a patrol car stationed at a mileage marker. 4 minutes later, the car passes another patrolman at a marker that is 5 miles from the first. The driver notes that the speedometer registers 55 miles per hour. Can the highway patrol use the mean value theorem to prove that the driver was exceeding the speed limit of 70 miles per hour? Why is he driving 50 and 55 then? At some time between the two mileage markers. Does this one seem more difficult? Or just because of the way it's presented? Okay. $22. Actually, it might be empty, right? Yep. Ooh. I feel like I should like try to call out ghost desks just to get you guys nervous. 25. Now, my guess is we're going to kind of do this as a whole class. You're just going to be the writer. So when it mentions the 50 miles per hour and the 55 miles per hour, what are those? Does anybody know what those are considered? I would consider those to be the derivative, the instantaneous derivative. We're getting there. We're doing this as a class. You're just the writer. So when you're driving, I mean, like you have a road that's got distances, correct? Okay? And you can figure out your average speed by figuring out how far you went over how long a time interval. That would be average speed. But as you're stepping on the gas pedal on a car, right, whatever the speedometer says is your current instantaneous speed. The 50 and 55 up there aren't going to take part in the problem, to be honest. They're just there to show that the guy was going under the speed limit. So the mean value theorem says that you are guaranteed that the instantaneous has to be the same as the average at some point. So to me, this is basically telling us that we want to figure out the average speed because it told us how far they drove and how long a time. And if that average speed is above 70, then you are guaranteed at one point that person went above 70 because they were below it both of their times. So that's what this is asking us to do, even though it doesn't really say. Because when you're driving, that's a continuous function. Your foot is on the gas pedal. I mean, we'll just pretend that the brake wasn't used. But your foot was on the gas pedal the whole time at some point. Okay, so we need to figure out the average speed. How far did we go over how long a time length? $5 miles. So write down 5 miles on the top of a fraction. Maybe bigger than microscopic. Thank you. My sarcasm must come out a lot more when I'm not feeling good because I was just roasting people in first hour on accident. And they're only ninth grade. I don't know how they took it. Okay, time length. How long did it take to go 5 miles? 4 minutes. So we need to change 5 miles over 4 minutes into miles per hour. Now there's different ways to do this. I'm going to guess most of you are semi-comfortable with, what was it called? The unit conversions from chemistry? What did they, no, they didn't call it unit conversions. They, what did you call it? I don't think it was called train tracks. Oh, are you talking about the equal sign train tracks? Oh. Oh, then that must be a different teacher saying it that one. Oh. How'd we get that? I don't know. How'd we get that? You just like randomly wrote the answer.
Well, we need to multiply that by 15 to get to 1 hour, so I multiplied the top by 15 too.
Okay, that works. Nope, that's one method. I would bet other people would do different methods, but that one's absolutely great. Okay, so you basically changed it to 60 minutes. Yep, okay. So 75 miles an hour, that is the average speed.
That's the is.
So, yeah, I mean, like this one, we don't necessarily have to have a formal way of writing the answer.
Oh, that's what we did. Okay, I see.
Oh, yeah, distance divided by time. Miles per hour kind of tells you the order to divide them. We were trying to prove that the average speed was greater than 70 because that guarantees that the person was going greater than 70 at some point. You just gonna sit there and text the entire hour? You wrote like 20 texts in that 2 minutes. Put your phone away. I am in here, even though I don't feel good, because I didn't want you guys to get behind, because I was already gone Friday. You apparently not. Thank you. Very nice job, Caroline. You had a tough one because it was not a regular question. Okay, this one gives you a picture. It says we have 5 minus 4 over x. Find all values of c in the open interval from 1 to 4, guaranteed by the mean value theorem. Now, let's do this one a little more official, and then we'll be done for today. Okay, that's 33. Excellent. Yeah. Okay, before we do the problem, we have to check that the criteria are met. Okay, to be able to use the mean value theorem, is it continuous between 1 to 4?
Yeah.
How do you know? Oh, okay, let's pretend we don't have a picture.
Okay.
So just an equation. How would you know?
Well, the only hole is when x is 0.
Perfect. That's a good way of saying it. The only undefined value is at 0. So it's not continuous at 0, but we don't care because we're only looking from 1 to 4. All right, good. Continuous, CONT, check. Right that.
Oh.
Continuous, checked. Whoa, that's big. You're anti-Carolyn. Okay. Well, that's weird to change colors, though.
Yeah.
All right, we'll go with it. What's the next thing we have to check for? Wait, let's call on people. That's more fun. Okay, what's the next thing we have to check for? The other person who's been on his phone or sleeping the whole hour. We checked if it was continuous between 1 and 4. Next, we have to check, I think you said it, differentiable. Nice.
Yeah.
How do you know?
Well, I just looked at the picture.
Oh, jeez. If we only have an equation, how do we know if it's differentiable? Find the derivative.
That sounds like a lot of work.
Well, we need to do it anyway during the problem, so
Okay. So it's 4 over x, and then it's low d high d low.
let's not do that.
Okay, then
I mean, it's not wrong. It's not wrong.
you're gonna end up with like 4 over x squared.
Write it as 4x to the negative 1. And then you can use power rule.
Okay. So then, I don't know. It's easier to do.
Really?
Yeah.
All right. Negative 4x to the negative 2. Oh, this should have been a negative to start with. Yeah. Thanks. You didn't write down the beginning of the... That was my fault.
So this is a positive then?
This is supposed to be minus 4x to the negative 1 because it was a subtraction in the problem.
Okay. So it's
Okay.
4 over x squared.
Correct. 4 over x squared. So which values are undefined in the derivative?
0.
0. Same one. Okay, so it is differentiable from 1 to 4 because 0 is not in 1 to 4. Okay, nice. So continuous check, diff check. What the heck? My smart board is insane. So if you are looking at the derivative, 4 over x squared, the only value that is undefined is at 0. We are checking if 1 to 4 is differentiable. Yes. So it's differentiable from 1 to 4 because you'll get an answer from 1 to 4. Okay, now the actual problem is f prime of c equals the average slope. We could probably have somebody else go because you've done a lot of writing already. An early number, 5. Okay, we'll give you some more room here. So do you want me to have you write down the formula to work from? So yeah, f prime of c. Yep. F of b minus f of a. And that, like I said, that'll be written in the questions so you don't have to memorize it. We're basically just going to fill all that out now to find the answer. Nice. You even remembered the C. Okay, f of b. We can use the picture if we want. I don't know if it's going to help. From 1 to 4. So 5 minus 4 over 4 is 4. 5 minus 4 over 1, 1. Over 4 minus 1. Well, that worked out nice. Okay, so we got 4 over c squared equals 1. Yeah. Hey, this is hurt. This is painful for me to watch.
What?
You're just writing everywhere.
Yeah.
Oh. You guys are killing me here. How do you guys not learn organization by now?
It's perfectly organized.
Yeah,
And then it goes down.
it is perfectly organized in your mind.
Yeah.
It is not organized for others to view. So 4, you multiplied both sides by c squared, it looks like? Okay, that's correct. Yep. Now, last question, what should we answer for this question because it's not plus and minus 2? How come just 2? But you're right.
Isn't this only a positive slope this entire way?
Yeah, you were, I mean, everything you just said was correct. It's only going to be 2 because that's the only answer between 1 and 4. Plus and minus 2 are both correct, but we were only looking from 1 to 4. Nice job.
So the only reason they gave you the 1 and 4 in
You definitely have to be given that.
the, yeah, so,
That's the interval that you're looking at.
okay.
If you weren't given that, you wouldn't be able to do the problem.
But you can also use it to figure out, like, the final answer, whether it's positive or negative.
Yeah, oh, definitely, yeah. Yeah, because there's frequently going to be many times where you'll get multiple answers down here, but you only want the ones in the interval.
Will there ever be a time where it's like multiple?
The very first example that we did together had multiple spots. So it just depends on what the equation looks like.